Hi everyone! This video is to talk about how to make a confidence interval for a standard deviation. This is my 15th take, and just however this turns out, this is what we're going with. I'll do my best, but I am so done trying to make this video without errors. Okay, so what I'm looking at here is the handout that I posted in your Canvas course, and you're also going to need the secondary handout I posted with this cool looking table to help you kind of navigate your way through how to calculate stuff for a confidence interval. The third thing you're going to need is Excel so that you can do the calculations with me. All right, so going back to the handout, this one is multiple choice, and so it kind of gives away what you're supposed to do in the problem. So because all of the answers have a sigma in them, this must be a standard deviation problem. Since they're all intervals, it must be a confidence interval problem. But let's pretend like we didn't have that information because we won't always have that information. And let's try and just read through the problem and figure out how we were supposed to know this is a confidence interval problem, and how we were supposed to know it was a standard deviation confidence interval problem. Okay, so I'm going to bust out my highlighter and I'm going to read through this problem. Use the given degree of confidence in sample data to find a confidence interval for the population standard deviation. Okay, and those two gave us all we need to know that one, confidence interval tells me to go to this handout, and two, standard deviation tells me to look for that keyword on the handout and just use this row. Okay, so assume that the population has a normal distribution. This is not trying to mislead you into using the normal distribution. Try that again. It's not trying to mislead you into using the normal distribution. It's just trying to tell you that you've made the minimum requirements to be able to calculate this confidence interval using the sigma squared distribution. So this is just letting you know that you've made the requirements. Then it tells you information about how to round the answer. And then it gives you the raw data for the sample. Okay, and lets you know that it wants a 98% confidence interval. So we'll need that when we have to go into Excel and calculate the critical values for this confidence interval. So going back to our handout, let's go ahead and take a look at this big, giant, kind of scary looking equation over here. Zoom in some. So I've got to be able to do this equation, which means that I'm going to need a chi-squared value on the right, a chi-squared value on the left, the degrees of freedom, n-1, and standard deviation squared, which is also known as variance. We can always just calculate standard deviation and square it. When we're all done stacking these two fractions, we've got to remember to take the square root. So if we don't take the square root, we're going to be finding the confidence interval for the variance instead of the standard deviation. Okay, so with that information in hand, let's scroll over to what this handout says we need to use in Excel. And that is chi-squared inverse on the right and chi-squared inverse on the left. Remember, Excel always defaults to left, so they don't write it. They only write it when they're actually going to use right instead. Okay, so now that we have this information for Excel, I'm supposed to use chi-squared. I got to figure out how to use chi-squared. So it means I got to figure out how to apply this 98% confidence interval information they gave me. All right, that means that I need to be able to draw a chi-squared a chi-squared distribution, which looks like a happy whale. Okay, so I'm going to draw the whale for a second and then I'm going to erase it. Here is my happy whale, little eye, and a spout. Okay, chi-squared distribution looks like a happy whale. Okay, I'm looking for a chi-squared distribution that has 98% of the data in the middle, and I'm looking for the two values that cut off the remainder of the data. 98% is in the middle, then 2% must be left over for either side. So that means 1% is over here, and 1% is over here. So these are the two values that I'll need when I go into Excel and fill out the chi-squared distribution on the left and chi-squared distribution on the right. The other value that I'll need is the degrees of freedom. So going through here and counting, I have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So that means the degrees of freedom will be n-1. I'm sorry for this terrible penmanship. I'm using a mouse. n-1, which will just be 7, because n was equal to 8. Okay, so we have enough information to go over to Excel and start calculating these two things. So I've got chi-squared, we'll call it on the left. I've got chi-squared on the right. And I need my standard deviation. To be able to calculate standard deviation, I'm going to enter STDEV. Then I have to choose between P and S. If you recall from lecture, the P stands for population and the S stands for sample. Since we're dealing with a sample, we're going to choose .S. Okay, I'm going to highlight the data and hit enter, and now I have my standard deviation. So now I have to calculate chi-squared on the left. So chi-squared inverse. It wants the probability, going back to that fancy drawing we made, to the left of this critical value is 0.01. So 0.01. And the degrees of freedom, as we just said, are 7. Okay, chi-squared on the right. I will have the exact same value, 0.01, and degrees of freedom is 7 again, but since I'm using the .RT, I should get a larger value now, 0.01, and 7. And if you recall from the lecture video on the chi-square distribution, the middle of this hump is pretty close to the degrees of freedom for this particular data set. So that means if we were calculating a high value and a low value, we would want something less than 7 and something more than 7. And we can double check that we got something less than 7 and something more than 7. So at least we have some sort of ballpark way of figuring out whether or not our solutions here are correct. I'm going to zoom in a bit so you can see these values. And then we're going to start with the calculations from our handout. So zoom out a bit so you can get a handle on where we are in this handout. We need this numerator, n minus 1 times the standard deviation squared. Notice it's the same for both fractions, so I only have to calculate that once. So I'll name that numer. And that is equal to 7 n minus 1 times the standard deviation squared. Okay, and that value is 0.84. And showing the calculation one more time, it's 7 times the standard deviation squared. Okay, and then I have to calculate the large and small value for this interval. So remember, intervals in mathematics, they'll read from small number to large number. So I just have to find the small number and the large number. Small and large. Okay, so I know that no matter what, I need to square root the numerator divided by the denominator. Now I have to choose which one of these is the correct denominator. So going back to just regular fractions, the larger the denominator, the smaller the number, right? So 1 over 10 is a bigger value than 1 over a million. So if I'm trying to calculate a small value, I better divide by the big number. Okay, and then equals square root, and the numerator again. And since I'm trying to make a larger value here, I've got to divide by a smaller value here. So it looks like I go from about 0.21 to about 0.82. Going back to our handout, look for that in the solutions. A 0.82 and a 0.21, and it looks like it is right here at C. Okay, so we're going to do that one more time. We're going to do it for problem 33. This one does not have the raw data, so it'll be one less step that we have to do. Going back to read through this problem again, we have use the given degree of confidence and sample data to find a confidence interval for the population standard deviation again. So we're using the same row on our handout, the same calculations in Excel, and the same confidence interval. This one doesn't give us raw data, so we've got to read through this problem and collect all the pieces that we need. A sociologist develops a test to measure attitudes about public transportation, and 27 randomly selected subjects are given the test. 27 randomly selected subjects, that means n is equal to 27. Okay. Their mean score is 76.2, and before we get thrown off by that, let's go back and double check. Nowhere in here is a mean, so that is not a piece of information that I need for this problem. So I'll just skip right over it. And their standard deviation is 21.4, so that means S from the sample is equal to 21.4. I know from the calculations I just did and from the handout that I have here that S is a part of these calculations, so I don't want to skip over that piece of information. Finally, construct the 95% confidence interval for the standard deviation sigma of the scores of all subjects. So the confidence interval, that I will need as well. I'm going to use this when I draw the distribution. So this time, the distribution will still look like our happy whale. But now instead of 98 in the middle, we'll have 95. Oh, this is so hard to draw with a mouse. I'm so sorry. That's 95. Okay, there's somebody at the door. Lost my rhythm. Let me get back into this. So we have 95% in the middle, which means 5% is left over for either side. And that means 2.5% belongs over here. 2.5. Just like that. And then another 2.5% over here. That says 25%. Let's fix that. 2.5% has a 0 there. Okay, and then 2.5% over here as well. Okay, so I have everything I need to be able to calculate the chi-squared on the left and chi-squared on the right using my Excel. Keeping in mind that the degrees of freedom are now 26 instead of 27, because it's always n-1, and we had 27 randomly selected people in this new problem. So going back to my Excel spreadsheet, I no longer need this data, just going to distract me. I still need chi-squared on the left, chi-squared on the right. I still need a standard deviation. And unfortunately, I did not have the wherewithal to put in my degrees of freedom separately. So let me see if I can move these. And this will allow me to add a degree of freedom. So if I have to do any more of these calculations, I don't have to keep editing all the equations. So chi-squared on the left, I have now 0.025 and 26 instead of 7. Chi-squared on the right, I have 0.025, 26, and 27. And I can see that these two numbers surround 26. Remember, this distribution is not symmetric, so they won't surround it perfectly, but at least I have a number less than 26, and I have a number more than 26. The standard deviation from the problem was 21.4. So 21.4. Okay, and then I just have to go edit this numerator to use 26 instead of 7. Okay, and then it's updated all of my equations because I built them in to have the square root and to work off this numerator and these two values. So I don't have to go back in and edit these anymore. I just have to look for the two solutions that match. So I've got about 16.9 to 29.3. And 16.9 to 29.3 is B. Okay, so even though I didn't have to do these calculations, I'm going to show them one more time just to go over what's being calculated there. I've got the square root with the numerator divided by the large number, and the square root with the numerator divided by the smaller number. And both of those are coming from this confidence interval handout. I hope you found this video helpful. I made it through in the take that I was hoping for, and I hope you guys are healthy at home.